Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery that all started with a big bang.
Hello, welcome to my video about the theory of parallel universes. In this video, I will help you to understand the theory of parallel universes like I do with the help of a thought experiment. But first, a little history about the founding of the theory. In 1954, a young Princeton University doctoral candidate named Hugh Everett III came up with a radical idea that there existed parallel universes exactly like our own universe. These universes are all related to ours and they branch off from ours, and our universe is branched off from others. Within these parallel universes, our wars would have had a different outcome than the ones we know today. Species that are extinct in our universe would have evolved and adapted in others. In other universes, we as humans may have become extinct. According to Niels Bohr, a Danish physicist, when we observe a quantum object, we affect its behavior. Observation breaks an object's superposition and essentially forces the object to choose a different wave function. For example, say an object's wave function is both a particle and a wave. When a physicist measures the particle, there are two possible outcomes. It will either be measured as a wave or a particle. When a physicist measures the object, the universe splits into two distinct universes to accommodate each of the possible outcomes. So a scientist in one universe finds that the object has been measured in a wave form. That same scientist or a different scientist in another universe measures the object as a particle. This also explains how one particle can be measured in more than one state. So the major question is, do parallel universes really exist? Well, according to the many worlds theory or the parallel universe theory, we can't truly be certain, since we cannot be aware of them. But a thought experiment can be done to give us an idea of how this theory works. This thought experiment is called quantum suicide. This idea was first posed by a Princeton University theorist named Max Tegmark in 1997. In this thought experiment, a man sits down before a gun, which is pointed at his head. This is no ordinary gun. It's rigged up to a machine that measures the spin of the quantum particle. Each time the trigger is pulled, the spin of the quantum particle is measured. Depending on the measurement, the gun will either fire or it won't. If the quantum particle is measured as spinning in a clockwise motion, the gun will fire. If the quantum particle is spinning in a counterclockwise motion, the gun won't go off. There'll be only a click. Nervously, the man takes a breath and pulls the trigger. The gun clicks. He pulls the trigger again. Click, and then again it clicks. The man will continue to pull the trigger again and again with the same result. The gun won't fire. This gun is working correctly with loaded bullets, but no matter how many times he pulls the trigger, the gun will never fire. So he will be there for an eternity without dying, therefore becoming immortal. Okay, let's suppose we go back in time to the beginning of the experiment. The man pulls the trigger for the very first time, and the quantum particle is now measured as spinning clockwise. The gun fires, and he is dead. But wait, the man already pulled the trigger for the first time, and an infinite amount of times followed that. And we already know the gun didn't fire. How can the man be dead? The man is unaware, but he is both dead and alive. Each time he pulls the trigger, the universe is split into two. It will continue to split again and again each time the trigger is pulled, thus creating an infinite amount of universes. So you see, the parallel universe theory could actually be true, but it would really be impressive to see a real live experiment done to prove this theory. Well, it looks like that's all the time we have for today. Thank you for watching my video, and I hope you learned something new today.